So we have C of Q, output, firm sells some product, input goods used to make whatever the output is. This is last time. C of Q, again, if I can remember something, the least amount of money needed to buy the inputs that will produce exactly output Q. I'm going to just get a phrase that would help me. That would be it. Fixed costs, the cost of making nothing. That is a little subtle. Pick a victim. Here, be my victim. If you don't make any steel, will you have any costs involved in making steel? You personally. No, he won't. He does not own a steel plant. Okay. But if I ask that question to the head of one of the large steel corporations, ArcelorMittal, would I get the same answer? No, right? Steel company already has built steel mills, and it has to pay for them whether it makes it or not. So fixed costs are costs you cannot avoid. And it's very situation specific. It means that you've already invested in something. Let's think of a retail establishment. Could be a coffee store. That would work. Do they have fixed costs? What happens if they don't sell any coffee? What do they still have to pay? Rent, yeah, for sure. Maybe other things too. So they definitely have fixed costs. If they have zero output, their costs are non-zero. Those are fixed costs. I'm kind of mathematical. I might just remember it this way. Fixed costs are costs of zero, especially if I'm trying to remember a lot of this stuff. Variable costs are all the costs that are not fixed. So we're not going to have very many lines here before we get all this stuff defined. So literally, C minus FC. Average cost, you take cost, you divide it by quantity. You get average cost. Average variable cost, you take variable cost divided by quantity. Luckily, there's not many more to come. Right? We're almost done here. Average fixed cost, take fixed cost divided by quantity. See the pattern here? And we can learn something about average fixed costs. Fixed costs are the amount that you pay even if you produce nothing. It's a number. And so if I divide it by quantity and I make the quantity large, what's going to happen? What will happen to fixed cost is Q gets very large. It can vanish, right? Because it's just some number divided by Q. Q large, very small. That's the essence of a retail business. You have all of these fixed costs, and they're big for you. And if you can push a lot of product out the door, be it coffee or whatever else, then suddenly you're taking your rent and dividing it by 10,000 coffees. That looks a lot better. So fixed costs, average fixed costs. On the contrary, your average fixed costs go through the roof if you make nothing, because something divided by zero is a really, really, really big number. So we know the shape of average fixed costs. And that's going to help us because later we want to know the shape of average cost. And average cost is average fixed cost plus something. And if this thing goes to infinity, as you go this way, then this plus something goes to infinity. So you just learned that as cost gets very small, average cost is going to have to go through the roof, at least if there are any fixed costs. So that's a good thing because it tells us one side of our story. Marginal cost, last new one. There's a lot of ways to define it. If you do not like the calculus, you'll go this way. It is the cost of making the next unit given that Q units have already been made. Right? It depends on Q. It's MC of Q, not MC. It is a function. Generally, we think of it as sloping upwards, and that may be good enough for the purposes we have in our class. If I did not know the calculus, I would use this as my definition. I'd say marginal cost is the cost of making Q plus 1 items minus the cost of making Q items, right? It's literally the cost of making the next item given I've already made and paid for Q items. Right? So that would be my, that's the definition that works for me. If you like the words better, go use the words. But this looks to me like you got it, right? In one equality and you're done. But that's our marginal cost. It's very convenient to reverse that and say C at Q plus 1 is approximately cost at Q plus marginal cost at Q. If I had done this with, instead of 1, a really, really small number, which as you'll see, would turn marginal cost into a derivative. What theorem is that? I want to know the cost of some number plus a little bit, and I know the cost of at that number, I know C of Q, and I know the slope of the function at C of Q. And so what's that? Yeah. Oh. What? Yeah, but there's a theorem that says this when you make 1 a really small number, which you did in the calculus. You all took calculus except for about 2 people. How about Taylor's theorem? Yeah? Okay. So that's what we're doing. What we've done is we've taken your entire calculus course, and the takeaway from it is you can approximate functions nearby by derivatives. And that's what we're doing. It's another view. Perfectly legitimate. At any rate, if you're not a calculus person, you could just say for our purposes, C of Q plus 1 is C of Q plus marginal cost. Close enough. You have to imagine 1 is a small number of additional things to make this work well. A chart. There's a chart like this in your homework, if I remember right. Here I have chosen Q, 1, 2, 3, 4, 5. Here I have chosen a function for C of Q. It's obviously Q squared, right? Here I have calculated out average cost. Literally, I took C of Q and divided it by Q. I didn't bother putting infinity in there if you like, you may. And I get average cost. Here I calculate marginal cost, the approximation. I take Q of 1 minus Q of 0. That's 1. I take that as marginal cost of Q. Notice that when you do it discretely, you also could have shifted the table up and chosen a different convention. I've just chosen a convention. That's the way. The reason why I define marginal cost at 0 to be Q of C of 1 minus C of 0. It's conventional. I'm not telling you that the other isn't okay. I'm telling you it's the way I did it. So if you do your chart and you match to my convention, you match to my definition, then your TAs will be happy because they'll be able to just take a look and say, oh, that's right. And then I just subtract. All I'm doing. 4 minus 1 is 3. 9 minus 4 is 5. Right? It works the other way, too. If I wanted to know C of 9, right? Sorry, C of 3. C of 3 is C of 2 plus the marginal cost of 2 equals 9. So that's your basics of cost, average cost, and marginal cost. If I asked you to do this and I gave you some fixed costs and I asked you to take them out, you would quickly enough create for me average fixed cost, right, average variable cost, and all the rest. And I believe that's one of your homework exercises. here I have it in a diagram. You will never see a diagram like this again. And the reason why is the things that we concentrate on are this one and this one. We'll never again graph this one. So everything we need to know to get the supply curve is in curves like this. But there they all are on one diagram. Now, so like 3 of you who have never been to the calculus may tune out for a couple of minutes if you wish. And I'll make it clearer how this is indeed a derivative. So let's look at our definition. Here is cost at q plus a little bit minus cost at q divided by the little bit. Right? If you put 1 in here, it would be what we have before. But here I've expanded it, and I've allowed it to be the additional cost per unit for a small number of units. So C of q plus t minus C of q divided by t. And what will happen as I make t small? That's the exact definition of marginal cost. But this is an object you should know well, the object on the right-hand side. What is that? What is it? Where did you spend a year of your life? Did you spend a year of your life in a calculus class? Yes? What was the primary first thing you would learn in a calculus class? Yeah, and what do you use the limits to do? You find a derivative. What's the definition of a derivative? That is the definition, okay? There's not much to discuss here. That is what marginal cost is. It is the derivative. Wait a minute, I gotta make sure this thing shuts up. Come on, thingy. Yeah, there it is. Now it'll definitely shut up. So, if it is easier for you to think of marginal cost as the derivative of the cost function, be my guest. If you work the problems, I've set my problems up so that they use the discrete approximation. So 98% of you need to humor me, and if it asks you to do a chart and calculate marginal cost, it probably would be better for them if you all did it the same way and did the discrete approximation. The other is actually just as good, in fact, better, and you could defend yourselves, but be nice. And so, if you haven't seen this before, here is C at Q. Here's C, right, black line, and here is Q plus T. And so C of Q plus T, right, minus C of Q is going to be this vertical distance, and T, of course, is going to be this horizontal distance. And so the slope of that blue line is C of Q plus T minus C of Q divided by T. And there's the T, and there's the C of Q, right, just as I said. And here I have done it again, but instead of T being large, I made T a little smaller. And if you keep doing this, you'll end up with a tangent line down here. And so the slope of the tangent line is the derivative is marginal cost. Now we've done half of your calculus course. Now we're done with calculus. Although I'll show you a couple other places where the calculus works better than what we're doing. Okay, now we're going to assume fixed costs are not 0. AC of 0 is average variable cost of 0 plus average fixed cost of 0, and average fixed cost of 0, we already showed go through the sky, right? So now we know if you have fixed costs, then the average cost curve will be going to infinity as q goes to 0. So it's going to go up on one side, at least as you go to 0. I got bored, so I can do this. Okay. So somewhere or other, it's got to start going up in this direction. I don't yet know what happens over here. I'm going to make an assumption. I'm going to make an assumption that marginal cost is increasing. It might be true that it's decreasing to begin with, and I think I just don't care. I think what I care about is that it eventually increases. You can also learn one more thing. Right? What's the difference between AC and ABC? As Q gets large, it's always average fixed cost. And what happens to fixed cost as Q gets large? Where do they go? To what number? To 0. So when you draw this diagram, if you put average variable cost and average cost on the same diagram, you know as Q gets large, they just get very close together.
Wouldn't marginal cost decrease because the cost of producing one extra little bit of that good would just go down after time?
Okay, so you want to talk about why at this point. Let's talk about why. So the story is you go out and you buy the steel mill, right? You plunk down your money for it. And it may well be that if you try to make a very small amount of steel, that's very hard to do. The thing was set up to make a large amount. So you might believe marginal cost goes down as you start using your plant the way it was meant to. But eventually you hit the other side of this argument, and the plant was scaled to make 10 million tons of steel, and here you are making close to 10 million tons of steel, meaning you're operating 24 hours a day, 7 days a week, you don't have time for maintenance and stuff anymore. And so the plant capacity is what's going to force the cost through the roof. Right? And you're going to suggest to me that then the reality might be the costs come down, and then they stay level for a really long time, and then they climb very steeply, and that might be the reality. But I'm not going to draw it that way. I'm not going to have a big flat bottom. So what I want to work through is this fact. Marginal cost crosses AC, and same argument for ABC, at its bottom. Ooh, it's you, it's not me. Ooh, no, you can sit there. Oh. I'm glad somebody else has been embarrassed in this class besides me. Usually it's like, yours go up all the time and I start keeping score at 17 to 1, but this year it's 1 to 17. I'm learning less. So let me do a demonstration about marginal and average. So instead of cost, we do height. So we need a small group of volunteers. The 3 of you will do. Get his attention, stand up. You guys up, the 3 of you, just up. Okay, they have an average height. It's around around the top of your head somewhere, right? Is our average height, perhaps at your ear, right? Okay, that's an average height. I have 3 people, I have average height of 3. Now we're going to get a marginal person. Is marginal less than average? Yes. What happened to the average height of this group? Did it go up or down? Okay, you may sit down. We have somebody who's really tall. Up you go. Okay, he's marginal. Is marginal greater than average? Yes. What happened to average? It went up. All right, that's all we have to say. Now we're going to do that with a little bit of math, but it's not going to be any more revealing. Well, they're giving you consolations. Okay, so you could really write this out. You could say, let's look at what happens. I have AC at Q plus 1. I want to compare it to AC at Q. You go through a whole bunch of algebra. What's AC? It's C divided by Q, right? And And so AC of q plus 1 is this, AC of q is that. And then I notice that this is C of q plus 1, but C of q plus 1 is also C of q plus marginal cost. And so I cleverly get rid of this q plus 1. Now I have C of q plus NC of q instead of it. Now I take this thing and I turn it into one fraction. I'm not going to spend time with the algebra. Multiply this by q over q. I multiply this by q plus 1 over q plus 1. I collect the terms, and I come to this. And so AC of q plus 1 is greater than AC of q if MC is greater than AC, and vice versa. So now I know if AC is over, I'm sorry, if NC is over AC, AC has to be increasing. If it's below, it has to be decreasing. It's the exact same thing we did with three people and their hikes. So here's my picture. I know AC is coming down to begin with because of the fixed cost. I've assumed MC is going up, right? Here I've made it go down at the beginning, but you notice it's irrelevant to anything. Unless you love the calculus, in which case at some point it will create a first-order condition that doesn't meet the second-order conditions. And so we will ignore it. If it crosses at all, it has to cross here. And I'm going to draw them so they do cross. This is the bottom. So when you draw this diagram, you're going to draw it a lot. Draw it so MC comes through the bottom. Same exact argument for ABC. Exactly the same argument. It comes through the bottom. I'm being kind of agnostic what happens out here, except for it's getting further away. Here, these things are getting closer and closer together. This is your standard diagram. Yeah? Your costs other than your fixed costs, right? So later it will, in the lecture Max will give you a week from today, it will turn out that if price is so low it's below average variable cost, you should produce nothing. Well, that makes sense, right? The minimum point of average variable cost is $4, and price is only $2. You've got to be losing at least $2 on everything you sell. So why do it? And that'll be the shutdown point, and that's a lecture away. Now we're working towards our rule. Our rule is going to be price equals marginal cost, and that is going to be the supply curve. And we make an assumption about firms. Firms maximize their profits. I'm just going to say it's a bold assumption. If you had a lot of time, we could talk about alternatives. There are alternatives. We take it as a good first-order approximation. Profits I write as revenues. Price times quantity is called revenue. Cost is obviously called cost. So revenue minus cost is called profits in the economics literature. Any accounting types out here? Anyone read 10Ks of firms and other such great stuff? Well, there they won't use the same terminology. There they're going to use terminology like earnings. So if you're going into the business world, that means you're going into the real world. You probably ought to get yourself a little bit of knowledge about their terminology and what is earnings and what is earnings before taxes, et cetera, et cetera. That's another world I'm not going there for the moment. So this is what I'm assuming. Firms choose output to maximize profits. Second thing I'm assuming is pure competition. Pure competition means the firms accept the market price as given. They don't believe what they do will change it. An example of that is American farmers producing wheat. There are a very large number of them. No one of them believes by selling a little more wheat or a little less wheat, she will change the price of wheat. That's the assumption of competition. And then we're going to assume it. There are other models. Take another course. You can have them. You can learn about monopolies and oligopolies and the like. But here, we're just going to start with the competitive model. So let's go back. What do firms choose? You can all say it in unison. You can read it off the board. Firms choose, and they take as given price, right? They choose Q. They take as given P. That defines this model. So if you keep that in your head and you're asked a question about this model, you will not answer me about how the firm does something with P. So we're just going for the competitive model, and in that, firms choose Q. Well, how do they choose Q? They choose it to maximize their profits. We will do half of this today, although his question gave you the other half already. Firms either produce nothing, or they produce where price equals marginal cost. Can firms produce negative amounts? No. So that sets up a situation where they have profits, and the two cases really are, here's Q, and that's the place where these are profits. I'm on the board drawing a simple diagram of profits, and I have an interior solution, and you know the other possibility is something like this, where it's Q equals 0. Yeah? So today we're going to look at that one. Next time we'll tell you when this is profits. Profits are maximized here at 0, right? You look at me quizzically. Why? Why am I giving a quizzical look? Well, you can ask a question. It's okay. No, just quizzical. Okay. So right, if you're maximizing some function and you're doing it with greater than 0, doing it on some half-open interval, then one possibility is it takes its maximum on the edge. And in that case, you won't get any first-order-ish conditions like price equals marginal cost. Instead, you'll just get here, it's do nothing. So these are the two possibilities for where the function can be highest. And this is the one we're working on today, the interior.